the second case of calculating the effect size is known as risk ratio and the odd ratio. Now, understand. In this case, suppose you divided the two groups into two parts, treatment group and control group. So you can see that you are having the two groups, treatment group and control group. And after that, there are 100 people in group number 1. There are 100 people in group number 2, and you give medicine in group number 1. As a result of the medicine, the 5 people died and 95 survived. In control group, 10 people died and 90 survived. So this case is very, very popular in actually medical science. So if any of you is belong to medical science, so normally what happens, you compare the two group of patients and you find out that how many survived in treatment group and how many of them survived in the control group. Now, in this chart, you can see this A, B, C, D. So this A, B, C, D is a standardized notation. We always keep these values A, B, C, D because all the calculation, all the formulas are with respect to A, B, C, D, N1, N2. And N1 is always the value or number of patients in the treatment group, and N2 is always the number of patients in the control group. So all these values are fixed values, means A, B, C, D, N1, N2 are fixed. Now from these two values, we can calculate the risk ratio and the odd ratio. Now what is the risk ratio? Risk ratio means the probability of died in the treatment upon the probability of died in the control group. For example, in this case, you know that A upon N1. A upon N1 means 5 upon 100. So it is 5%. It means the probability of death in treatment group is 5% and the probability of death in control group is 10%. So risk ratio is 1 upon 2, right? In this case, the simple risk ratio is upon 1 upon 2. Similarly, the odd ratio is calculated by how many death divided by how many not died. So number of persons died upon survived in treatment group and number of persons died upon survived in the control group. So this ratio is known as odd ratio, right? So I hope you have clarity now how to calculate risk ratio and how to calculate odd ratio. And in medical science or in experimental design, it is very common. Okay, so once we have clarity between the risk ratio and the odd ratio, now in medical science, the objective of doing meta-analysis with respect to risk ratio and the odd ratio is that what is the effective survival in this particular vaccine or in this particular medicine. Like a lot of meta-analysis studies are going on in case of corona nowadays, and most of these studies are based on risk ratios and the odd ratios. So if you have clarity on the risk ratio and the odd ratio, now I'm going to tell you how to do the meta-analysis, how to calculate the effect size on this kind of data set. So in this kind of data set, this table is required, and this table, you have to pick this table from all the studies. So listen carefully. I hope you understand that. If anybody want to conduct a study on meta study on this kind of result, this kind of data set, so what you want from the different studies, the data of this table, right? Okay, so now the formula of calculating the effect size in risk ratio and the odd ratio. Okay, so this is odd ratio. It is wrong. OR means odd ratio. So this is by mistake. It is a odd ratio. I will correct and send you. So first of all, you can see that effect size is nothing. It is the log of the risk ratio, and we calculate the variance, and on the basis of the variance we calculate the weight, and after the weight is actually 1 upon variance, and on the basis of this formula we can calculate the value of the diamond. So only 3 formulas are involved in this in the calculation of the effect size. So effect size is calculated by this formula. I hope you understand what is A upon N1, what is C upon N2, and then you calculate the variance. From the variance you calculate the weight, and from the weight you can calculate the diamond. Similarly, I put the formula here, and now I'm going to show you the calculation of the effect size using the Jamovi, and I will show what is the result. So before that, I want to show you the data set, in which form you must have your data set. So case number 2 is about this. If I open the case number 2, I want to show you the data set. So in which form we should have the data set. In this case, if you want to apply meta-analysis based on odds ratio and the risk ratio, you should define what is A, what is C, what is N1, what is N2. So you must have these 4 values in the data set. Otherwise, you cannot apply the meta-analysis. So these 4 values must be there in your data set, right? So I hope you can see it. So we require 4 values. A means how many people died in experimental group. C is representing that how many people died in the control group, and N1 is the total number of samples in group number 1, and 2 is the total number of people in group number 2. So we are having 4 data set, 4 variables, and on the basis of the 4 variables, you can calculate the meta-analysis. Now I'm going to open this file in Jamovi, and I'm showing you how to do this. So this is Jamovi, and we want to open the data set first. So click on the data set. Let me open the data set. This is case number 2. And in case number 2, let me click on the measure, and I want to click on the dichotomous variable. Dichotomous because comes in the binary. Okay, now let's see. So software is asking how many incident in experimental group. That is my A. But actually, you can see there is a mismatch. This is a scale variable, and this variable is not a scale variable. So we have a problem. So let me go back to the data set, and I have to correct it. So you can see this variable is actually nominal, but the software wants this variable to be continuous. So let's double click it, change it to the continuous. Similarly, C continuous, N1 continuous, and this is ordinal. Continuous. This is also continuous. Okay. Now I think all the variables are continuous. Fine, good. So now let's move to the analysis part. So we are having analysis and data. If you want to see the data, you can click on the data. If you want to do the analysis, just go to the analysis. And let's go to the measure. And in measure, I want to analyze risk ratio. So this is the command for risk ratio. Okay. Now the software is asking how many incidents are there in the experimental groups. So software is asking for A. Then software is asking that what is the total sample size of experimental group. This is N1. Then next is how many incident in the control group. That is C. C is the number of incidents in the control group. Okay. Then what is the sample size of the control group? That is N2. And studies are this. Okay. Now you can see that all result you can see here, and this is my answer. All the studies you can see, we can see here, and but actually I don't know whether it's a odd ratio or a risk ratio. Okay. So let me check it. Model options. So there are different options you can see here. If you want to do the analysis on the basis of risk ratio, you should click on this. And if you click on the second option, you can get the answer on the basis of odd ratio. So first I want to see the risk ratio. And so you can see that I'm selecting the risk ratio based model. Fine. And you will get the answer here. So this answer is based on the risk ratio, right? If I want to calculate on the basis of odd ratio, you just click it and everything will be refreshed. And now your values are on the basis of odd ratio. So the value of diamond is 0.69. The value of the diamond is 69. And if I click on the risk ratio, the value of the risk ratio is 0.30. So 0.30, this is the diamond value. And these are the expected value from each study. The study where weight is very low, where weight is high, you can see the big body and the small bodies. Small bodies means high variance, and big body means more weight, less variance. And on the basis of this, we can calculate this diamond. So in this way, we can calculate the effect size of the different studies. So this is the case number 2, and